Okay, so for the excited state, which is this side now, the only difference with excited is that we're starting out in the ground state, like the previous video, but we're filling up the lower shells first, then going to the next shell. So a good way to start is look back at the ground state side of the sheet and say, okay, here's my starting point. How can I make this element, this atom, excited? And basically the way you do that is you choose an electron and you bump it up to a higher shell. So what I mean is, here's hydrogen. If we look back at what hydrogen looked like, it had just the number 1, and there was only one number there, which means that one electron was in that first shell. If we want to excite this electron, we would just have to bump it up to another shell. Now there's only one circle written here, but we could just bump it up by just adding another circle. So a way to do that is, okay, here's our 1 proton, and it was originally in that first shell, but instead I'm going to draw another shell and draw that 1 electron now in that second shell. So that new configuration is, well, how many electrons are in that first circle? 0. And how many are in that second shell? 1. Okay, so this is just one example. If we did helium, let's look back at helium. Originally, it was just the number 2 because there's only one shell here, but both electrons are inside. So with helium, you have a couple of options. You could bump up one of the electrons, or you could bump up both of those electrons. So here's helium. In the first shell, maybe we want to say, all right, 2 protons, 2 neutrons, and instead of bumping up both of them, let's just bump up one. And there's many right answers. When it comes to excited state atoms, there can be many correct answers. So we originally had both of those electrons in the first shell. Let's bump one of them up to another shell. This is now 1 dash 1. Notice how the total number of electrons is still 2, and all I've done is change the location of one of those electrons by bumping it up to a higher shell. Let's look at lithium. Lithium has 3 protons and 3 neutrons, let's say, and originally it had the configuration 2-1. 2 electrons in the first shell, 1 electron in that outer shell. The reason why we have that third electron on the outside is because we filled up that first shell completely. So what we could do is, one of the ways we could excite this is we could take one of those completely filled shells, right? This first shell is completely filled. Take one of those electrons and bump it up to the next shell. So instead of it being 2-1, we would take one of those electrons in the first circle, bump it up so that it would be 1-2. Total electrons is still 3, and all I've done is moved one of those electrons that was originally in the first shell up to the next shell. It's basically just bumping up electrons to higher shells. The only thing you need to make sure of is the total number of electrons remains the same. That's an N. That's one thing you have to worry about. The other is shell 1 can hold a maximum of 2 electrons. Shell 2 can hold a maximum of 8, and shell 3 can hold a maximum of 18. So the only thing you have to worry about is don't go over the max. Then you are breaking the rules, and it's not a correct excited state. So if you notice in any of these, we're not going over our capacity. in this first shell, we can hold a maximum of 2, but we only have 1, so we're not going over the max. In the second shell, a maximum of 8, we only have 2 in here, so we're not going over the max. Just make sure that the total number adds up to the original and that you're not going over the maximum.